This is 2.1, the meaning and properties of fractions. Identifying parts of a fraction. A fraction in this case is the numerator, which we'll call A, over the denominator, B. It's also saying your part out of your whole. So sometimes you see things that are like A divided by B or A over B. You might see a number slash B, so something like that. Where you have 1/7, for example. So if we drew 7 boxes, let's see if that's 7. 1, 2, 3, 4, 5. Let's make it a little longer. 6, 7. So we have 7 boxes, right? Because that's our whole. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Always good to double check. And you have one part of it. That means that out of the whole thing that you have, you only have one part that's shaded, because that's how much you have. The numerator is always the number that's on the top. Denominator, D. Derriere is bottom, is butt in French, so it's the bottom part of your fraction. Okay, so you have 3/4. You have the numerator, and you have the denominator. It's good practice to write it out every time. So the numerator in this case is the top number, which is 3, and the denominator is the bottom number, which is 4. The next one, A over 5, we have the numerator, which is A, and the denominator, which is 5. In this one, we have 7. If it's a whole number, you have to imagine that it's 7 whole pieces, so 7 out of 1. So we would have the numerator is 7, and the denominator, even though it's not there, would be 1. Proper fractions are a proper fraction is a fraction which the numerator is less than the denominator. So examples are 3 over 4, 1 is smaller than 8, so 1/8, 9 out of 10, 7 over 8, 1 over 2. So again, the number that's on the top is smaller than the one on the bottom. An improper fraction is where the numerator is bigger than the or equal to the denominator. Some examples are 6 over 1, or just saying 6, 8 over 2, 9 over 5, or 9/5, or 10 over 10, which is the same as saying 1. Again, this is 2.1, the meaning and properties of fractions. I'm not really sure if I said that at the beginning. I want to make sure you understand we're starting chapter 2, fractions, and these are the basics. These are the things that you need to understand when I'm saying certain words like proper and improper. What does that mean? Proper fractions are the ones that are going to be the smaller number on top, and improper fractions are going to be the ones where the smaller number is on the bottom. The next big piece of fractions is understanding where do they come from. So let's talk about fractions on a number line. If I was asking you to look at this first number line, notice that I labeled 0 and 1. If I was going to break this into thirds, we would need to have 3 sections. Now half would be right in the middle, but we want it to be a little bit more than half when it comes to thirds. It's like a third would be right about here. And then 2/3 would be right about here. And then this is your third one. So you have 1, 2, and then this would be 3 out of 3, or known as 1. If I wanted you to shade 2/3, you would show me a box for the whole set, and then you would shade 2/3 of it, or show me an arrow with it, or some use of the number line to demonstrate 2/3 out of the 3/3. 2/3 out of one whole set. Let's look at another example. We just identified 1/3 and 2/3, correct? Let's write those in again. So we have 0, right? We have our 1/3. I'm going to rewrite that because I can write it nicer. We had our 2/3. And then we had our 3/3. What if I wanted to have sixths? Break this into sixths or twelfths. So if I wanted this to be sixths, I'm going to switch to purple, or blue actually, 6/6. Right now I have 1, 2, 3, but I need 3 more. So now I have 1, 2, 3, 4, 5, 6 pieces for my 6/6. This would be 1/6, 2/6, 3/6, 4/6, 5/6, and then 6/6. What if I wanted to change it to twelfths? What if I wanted 12 out of 12? I need to double up all of these. So we'd have 1 here, 1 here, 1 here, 1 here, 1 here, and 1 here. Let's count and check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 12 pieces. This would be 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, and then 12/12. Why is this important? Why is knowing that if I split my 1/6 into half, I have 12ths, because 6 times 2 is 12 and I'm cutting it in half. Same thing with thirds to 6. Why is that important? Because that's when we start talking about something like this part here. Equivalent fractions, where they're the same value. 1/3 is equal to 2/6, which is equal to 4/12. They're the same value. And we can simplify fractions in the same way. Let's talk about those equivalent fractions. Fractions that represent the same number are said to be equivalent. Equivalent fractions may look different, but they have the same value when simplified. A fraction that can be either multiplied or divided to have the same number in the numerator or denominator can be equivalent, so the fractions that are equivalent to a half are, so we could do a couple as an example. A half we could multiply by 2 on the top and the bottom, and we would get the example 2/4. That's equivalent. We could do the same thing with a half, but multiply it by 3. And 1 times 3 is 3, 2 times 3 is 6, so 3/6 is equivalent. But we could also divide. So we could also do like 12 divided by 20, 12 and 12 24ths, and we could divide by 12. And when we do, 12 divided by 12 is 1, and 24 divided by 12 is 2. So 12 24ths is equivalent. Writing 3/4 as an equivalent fraction with a denominator of 20. I'm going to highlight that because I'm going to ask you to do this multiple times where you actually have to make the denominator whatever I ask you to make it. So I have 3/4, but I want you to turn it into 20ths. How do I ask you to get from here to here? What do you have to do? You're going to ask yourself, am I going to multiply or divide? Well, because I'm going bigger, I'm going to multiply. And what am I going to multiply by? 4 times what is 20? I know 4 times 5 is 20. So because of that, I'm going to carry that up to the top because it has to be the same on the bottom and the top. 3 times 5 is 15. So my answer is 15/20. Let's do another one. Write 5/6 as an equivalent fraction with a denominator of 30. We have 5/6 to start. I want the bottom number to be 30. What? 6 times what is 30? We know 6 times 5 is 30. So 5 times 5 is 25. Let's look at the next one. We have 3/4, and I want a denominator of 12x. How do I get from 4 to 12x? Multiplying by 4 times what is 3? 4 times 3 is 12. Add in that x, and you get 12x. So what is 3 times 3x? Because this has to be the same. 3 times 3 is 9, and then we add in that x. So the answer is 9x over 12x. Going on. We have 10 over 12. I want an equivalent fraction with a denominator of 6. In this case, the bigger number is now first, and I'm going to a smaller number. So this means I'm going to have to divide. But by what? In this case, 12 divided by 2 is 6. So 10 divided by 2 is 5. My answer is 5/6. And finally, we have on this example set 20 25ths, and I want an equivalent fraction with a denominator of 5. How do I get from 25 to 5? I divide by 5. So what is 20 divided by 5? It is 4. So 4/5 is my answer. The number 1 in fractions. There are 2 times when the number 1 is significant in fractions. When the number is the numerator and 1 is the denominator. And that signifies as like a over 1, or just saying a, the whole number that's on top. We can give that example for this situation. Like 5 over 1, which would just be 5. And that results again in it being whatever that top number is. So in this case, a divided by 1 is a. In the second significant situation, this is situation number 2, when two numbers are exactly the same, and the numerator and the denominator simplified end up being the result of 1. So we have like 4 divided by 4, which is 1. You might see pi divided by pi, which is 1. Let's try a couple. Simplify the fractions below. So when we're looking at simplifying the fractions, we see 24 over 1. And we know the number, if it's on top of 1, is just the number itself. So we get 24. When we have the two same numbers, 24 divided by 24, we end up with the answer 1. But sometimes we see that 48 divided by 24, we actually can divide both the top and the bottom by 12 or by 24, and we end up getting 48 divided by 24, which is 2, over 1, which is just 2. And the same thing with the last one. You could divide by 12, for example, though, to start. And when you divide by 12, you're going to end up with something that's not as close to what the 1 as you were hoping for. So 24 divided by 12 is 2. And 72 divided by 12 is 6. It's not as simplified as it can be, though. So we're going to do it again. Divide by 2 this time. And we end up with 3 over 1. Now these numbers cannot be simplified anymore. There's nothing I can divide by. So 3 is my answer. Comparing fractions. You must have a common denominator. Don't have them, create them. They have to be the same. You must have a common denominator to compare. You cannot compare anything unless it is the same bottom number. You're then going to sort your numbers or your fractions from smallest to largest. So we're going to start with an example. We're going to make all of these into common denominators. So we need to pick a number that they all have in common. And that is something that you have to practice a lot of. Something that 8 has, 6 has, 4 has, and 3 has. So 8 is what I'm going to start with, and I think 8, 16, 24, and then I could keep going, but I know that 6 times 4 is 24. I know 4 times 6 is 24, and I know 3 times 8 is 24. So 24 is the number I'm going to use for their common denominator. So let's start with 5/8. And I'm going to convert this to 24ths. Then I'm going to have my second one, which is 5/6, and I'm going to convert that to 24ths. Then I'm going to take my third one, which is 3/4. I'm going to convert that to 24ths, and then my fourth one, 2/3, and I'm going to convert that to 24ths. So I have, then I'm going to switch to my pen. I did 8 times what is 24? 8 times 3 is 24, so 5 times 3 is 15. 6 times 4 is 24, so 5 times 4 is 20. I know 4 times 6 is 24, so 3 times 6 is 18. And 3 times 8 is 24, so 2 times 8 is 16. Now looking at the top numbers, here is what I'm going to use to compare. Now I'm going to do them from smallest to largest because that's what it asked me to do here. Which number is the smallest number? You should be thinking 15 is the smallest, then 16, then 18, and then 20. So let's rewrite those now. We have 15 over 24, 16 over 24, 18 over 24, and 20 over 24. And now I'm going to convert them back to their original numbers. So 15 over 24 was 5/8. 16 over 24 was 2/3. 18 over 24 was 3/4. And then the last one was 5/6. And that's my solution. Write each fraction as an equivalent fraction with a denominator of 36. Then write them in order from smallest to largest. So in this case, I give you the denominator. I did the same thing in this one and I didn't realize it. But I will get into how to figure out, it's a denominator of 24. I will get into how I'm not going to always tell you and how you can figure that out sooner than later. So here we go. Denominator of 36 for each of them. So we have 5/9 to 36, 5/6 to 36, 1/3 to 36, and 5/12 to 36. I'm going to pause it. I'm going to let you see if you can figure it out and put them in order. Now that you've had a chance to practice, I'm going to get started. We have 9 times 4 is 36, so 5 times 4 is 20. 6 times 6 is 36, so 5 times 6 is 30. 3 times 12 is 36, so 1 times 12 is 12. And 12 times 3 is 36, so 5 times 3 is 15. I'm going to put them in order from smallest to greatest. So I have 12/36, 15/36, 20/36, and 30/36. That means if I look back, 12/36 is 1/3, 15/36 is 5/12, 20/36 is 5/9, and the last one is 5/6. And that is my final answer. And that is 2.1, the meaning of and property of fractions.